Welcome back to CIT 157 Module 6-1. If you have taken any basic computer courses before, like CSE 151, you would have learned binary number, decimal number, and hexadecimal number. Also you would have learned how to convert among them. This would be a short review. If you have not taken any those courses or have forgotten it, don't worry. In this module, I will talk about it in the beginning and I will let you practice them with pen and pencil. In each practice, I will give you answer. Read Networking Essentials Chapter 6_3. Before you deal with numbers, let's talk about data representation. It will give you the reason why you need study numbering system in IT field. Data representation is a term used to describe systems that represent values, either numerical values or alphabetical values. Electrical signals are used in the circuits that process information. Magnetic charges are generally used for storage on disk drives or other media. Optical storage using light is also a possibility, but is not in widespread use at this time. At this point, we can look at how we translate from a decimal system using 10 digits to a binary system using 2 digits. A single binary digit is called a bit. This comes from the first and last characters, binary digit, bit. A bit, B and it, is one piece of information. 1 byte is 8 bits. Have a look about kilobyte, megabyte, gigabyte, and terabyte. We use byte, B, as capacity unit of the memory. 1 kilobyte, KB, is about 1000 bytes. 1 megabyte, MB, is about 1000 KB, a million bytes. 1 gigabyte, GB, is about 1000 MB, a billion bytes. 1 terabyte, TB, is 1000 GB, a trillion bytes. Now let's see decimal number first. The system that we are accustomed to is the decimal system, or base 10. The decimal system uses 10 digits, 0 through 9, and each place represents a power of 10. We use decimal number every day, so we do not think much how it works. From 0 to 9, we use 10 numbers in decimal system. From 0, we add 1 to make the next bigger number up to 9. Then 9 is the biggest number in one digit in decimal, we expand another digit and make 10 in 2 digit. In 2 digit, we leave first digit and increase second digit up to 9. Then we increase first digit to 2 and put 0 in second digit. In 2 digit, 99 is the biggest number. So you should expand another digit and make 100 in 3 digit. The value 707 contains 7 in the 100s place, 0 in the 10s place, and 7 in the 1s place. In this activity, you will practice binary numbers. The binary number system is perfect for electronic computing devices to use to represent data. It has 2 digits, 0 and 1, so a 0 represents the state of an off signal, or no charge, and a 1 represents the state of an on signal or charge. In reality, a computing device stores and uses ranges of values, so if we had the possibility of a 100% charge as the maximum, 0 to 30% might represent off or 0, and 31% to 100% might represent on or 1. Binary uses 2 numbers, 0 and 1. From 0, you add 1 to make the next bigger number, which is 1. 1 is the biggest number in digit. To make the next bigger number, you have to expand 1 more digit. Then 10 is the next number. Adding 1, you can make the next bigger number 11. Then 11 is the biggest number in 2 digits, you have to expand 1 more digit and make the next number as 100. With paper and pencil, practice this first. Then see next slide for answer. This is answer slide for exercise 1. Now let's talk about how to convert binary to decimal. To convert binary to decimal, you have to understand position values. The most right side is the least number. The value of this position is 2 power 0. Remember, any number power 0 is 1. A binary number 10,001 is 1 of 2 power 4, 0 of 2 power 3, 0 of 2 power 2, 0 of 2 power 1, and 1 of 2 power 0. The result is 16 plus 0 plus 0 plus 0 plus 1 equals 17 in decimal. Look at decimal number first to understand binary position. A decimal number 345 means 3 times of 10 power 2, 4 times 10 power 1 and 5 times 10 power 0. So 300 plus 40 plus 5 equal 345. A binary number 1101 is 1 times 2 power 3, 1 times 2 power 2, 0 times 2 power 1 and 1 times 2 power 0. So 8 plus 4 plus 0 plus 1 equal 13 in decimal. If you practice them, you will be used to convert a binary number to a decimal number easily. For a binary number 1111, you will get 8 plus 4 plus 2 plus 1 equal 15 in decimal. For a binary number 1100101, the biggest position value is 2 power 7 which 128. So it is 128 plus 64 plus 0 plus 0 plus 8 plus 0 plus 2 plus 0 equal to 202 in decimal. Practice this with paper and pencil. This is the answer. Now let's talk about converting decimal to binary. In order to convert from a decimal value to a binary value, you have several methods. If the number is small enough, you can convert by a series of subtractions. In this case we'll convert 73 to binary. First, find the highest power of 2 that the number represents without going over. In this case, this is the 64, so the most significant value in the binary number is the 64's place. Subtract 64 from 73, which leaves 9 unaccounted for, so the next place where we have a 1 is in the 8's place, which leaves 1 unaccounted for, so the next place where we have a 1 is in the 1's place. The rest positions should be filled with zeros. As the result, 73 in decimal is 100, 1001 in binary. Practice these with paper and pencil. For 125, you should start with 64. For 234, you should start with 128. For 17, you should start with 16. For 65, you should start with 64. For 27, you should start with 16. This is the answer. Now let's talk about hexadecimal number. Hexadecimal uses 16 numbers from 0 to 15. It starts with 0 and up to 9 is the same as decimal number. After 9, we use an alphabet A as one bigger number than 9. We consider A is a symbol of one bigger number of 9. The same way, we use B, C, D, E, and F. So, A is 10 in decimal, B is 11, C is 12, D is 13, E is 14 and F is 15 in decimal. F is the biggest number in one digit in hexadecimal. You have to expand one more digit and make 10 as one bigger number of F. So 10 in hexadecimal number is 16 in decimal number. One bigger number of 10 is 11. You can increase hexadecimal number as the same way of decimal up to 19. 9 is not the biggest number. So you don't have to expand to make the next bigger number of 19. 1A is the next bigger number of 19 in hexadecimal. In 1F, F is the biggest number. Now, you have to increase first digit as 2. So, the next bigger number of 1F is 20. In FF, both are the biggest number in first and second digit. So you have to expand one more digit. As the result, you make 100 as the next bigger number of FF. Practice this with paper and pencil. This is the answer. To convert hexadecimal to decimal, the principle is the same as binary. A hexadecimal number 1A0F is 1 times 16 power 3, A times of 16 power 2, 0 times of 16 power 1 and F times of 16 power 0. So it is 4096 plus 2560 plus 0 plus 15 equals 6671 in decimal. Convert hex numbers to decimal. This is the answer. Examples of hexadecimal numbers usage are web colors, IPv6, and memory addresses. Now let's talk about converting numbers between binary and hexadecimal. This is a table that is showing all binary, decimal, and hexadecimal numbers up to F. For example, the decimal value 15 can be represented by the hexadecimal digit F and the binary value 1111. So, one-digit number in hex can be converted 4 digits number in binary. When you convert numbers between binary and hex, the principle is you always convert one-digit hex number to 4 digits binary number. From left side to right, make groups for every 4 digits in binary. Then you just convert each 4 digits binary number to one-digit hex number. Practice these with paper and pencil. Make every 4 digits from left in binary first. This is the answer. Converting hex to binary is the same as binary to hex. Just convert each one digit in hex to 4 digits of binary. For example, with 70A, 7 is 0111, 0 is 0000, A is 1011. So it is 111, 000, 1011 in decimal. You have to be careful to substitute a 4-digit binary number for the 0 or you will lose significance. For another example, with E1B4, E is 1110, 1 is 0001, B is 1011, 4 is 0100. So it is 1110 0001 1011 0100. Convert hex to binary. This is the answer. Now I will talk about using calculator. Warning. Before you use a calculator, you must know how to convert numbers manually. Just follow the rest of the slide to use a calculator. This is the end of module 6_1. In this module you have practiced how to convert numbers. I will see you in next lecture.